students, in the previous lecture I have discussed about how to use simulation by having one ATM to meet the service requirement of the average waiting time should be less than 1 minute. But we have seen that we are not able to achieve that service requirement. So, in this class I am going to discuss about by introducing new one more ATM, whether we are able to meet the service requirement or not. So, the agenda for this lecture is waiting line simulation with the two ATMs. After that, verification and validation. In the previous lecture, we have discussed that having one ATM is not helping to achieve the service requirement of waiting less than 1 minute. So, in this lecture, we are going to introduce one more ATM and check if you would be able to achieve the service requirement. So, now one ATM to two ATM. So, we extended the simulation model to the case of two ATMs. For the second ATM, we also assume that the service time is normally distributed with a mean of 2 minutes and a standard deviation of 0.5 minutes. The table shows the simulation result of first 10 customers. Look at the table on the right hand side. So, I have given simulation result for first 10 customers. In comparing the two ATM system result with one ATM result, we need two additional columns. Previously, there was only one column was there, time available for ATM, and now we have introduced one more column. We assume that when new customer arrives, the customer will be served by the ATM which is available first. That is the assumption. There may be two ATM, both are idle, but a new customer is entering into that room. So, he will go to the ATM which is waiting for longer time, which is idle for longer time. That is the one assumption. And when the simulation begins, the first customer is arbitrarily assigned to ATM 1, that is the second assumption. Now, I will explain the two ATM simulation model. So, here I have written the customer inter arrival time. This was randomly generated. As usual, this also follow uniform distribution, and arrival time you see 1.7 randomly generated inter arrival time. So, arrival time is 1.7. So, immediately he will get receiving the service. So, service start time 1.7. Then usage time, this follow normal distribution, this also randomly generated. Then the completion time is service time plus usage time, service start time plus usage time. So, 1.7 plus 2.1, so 3.8. So, time in the system is completion time minus arrival time. So, that is 3.8 minus 1.7. And the first customer is going to get the service from the ATM 1. So, the ATM 1 is available for service only after 3.8 minutes. So, the second ATM is free. So, look at the second customer. The second customer inter arrival time is 0.7 minutes. So, this arrival time I have written in the continuous scale. So, 0.7 plus 1.7, so it will be 2.4. Service start time. Now, you see that service start time. So, when we starting the service start time, he is comparing these two. What is happening for one ATM? Okay, the time available for ATM 2 is 0. So, he will directly enter into the ATM 2. So, there will not be any waiting time. So, he will take 2 minutes usage time. So, completion time is 4.4. How 2 plus 2.4? The time in system is 4.4 minus 2.4, it is a 2. Now, this updation is important. So, whichever is the minimum available time for the previous customer, for example, 3.8 and 0, So, 0 is minimum. So, the completion time will be updated for the second ATM. So, the time available for ATM 1 because it is not minimum, that will be carried to the next customer also. Okay. So, I will explain the whole process with the help of Excel. Now, I go to Excel, I will explain how to use 2 ATM simulation model. Now, I will explain bank with the 2 ATMs with the help of Excel. So, the inter arrival time follow uniform distribution. So, smallest value is 0, largest value is 5, and the service time follow normal distribution, mean to standard deviation 0.5. So, what I have done here, I have generated for 1000 customers. What is our target? So, after doing simulation for 1000 customers, we have to see what is the mean waiting time. So, for example, B16 is inter arrival time. So, for first 5 customers, so the values are static. So, look at B21. So, B21 I have used this formula A plus B4 plus rand. So, B5 minus B4, A plus rand B minus A. Like that, I have developed inter arrival time, I have generated inter arrival time for 1000 customers. Now, you see the arrival time. So, arrival time is 9.1 plus 0, that is C20 plus B21, because this arrival time I am writing in a continuous scale. Then service start time, here you have to see if C21 is less than or equal to minimum of I20 and J20, then the service start time is minimum of I20 and J20, otherwise C21. Suppose the 6th customer arrives at 9.1 minutes, but the ATM 1 and 2 will be available, ATM 1 is available after 5.8 minutes and ATM 2 is available after 11.3 minutes. Because this 9.1 is greater than 5.8, he will directly enter to get the service. Now, the waiting time is column 3 minus 2, that is a service start time minus arrival time. So, the service time is the service time which follow normal distribution, mean to standard deviation 0.5, that I have randomly generated. Now, the completion time is column 3 plus column 4, that is service start time plus service time. So, the time in system is column 5 minus 2, completion time minus arrival time. Now, how I am updating the time available? If I20, okay, I20 is for the 5th customer, okay, if I20 is minimum of I20 and J20, G21 will be updated, otherwise I20 will be updated. For example, here the I20, when we compare 5.8 and 11.3, the 5.8 is minimum. So, for ATM 1 the completion time will be updated 5.8 to 11.2, from 5.8 to 11.2. The second one, the 11.3 just carried to the next customer. Look at the 7th customer, inter arrival time is 2 minutes. So, the arrival time is 2 plus 9.1, 11.1 minutes. So, when he will starting to get the service, you see the previous ATM 1 and 2, ATM 1 is available on 11.2 minutes, ATM 2 is available at 11.3 minutes, but he is coming early. Early means 11.1 minutes, but he will started to get service only at 11.2 minutes. So, the waiting time is 11.2 minus, so service time, this is randomly generated. So, completion time. Now, you see the completion time is 13.6 minutes. Now, the ATM 1 completion time for the 6th customer is 11.2, the time available for ATM 2 is 11.3. So, this 13.6 will be updated wherever there is a minimum time available. For example, ATM 1 the minimum time available is 11.2. So, this completion time will be updated below the 11.2. So, what we are saying this logic that a customer will enter into the ATM which is waiting for longer period of time, which is waiting for idle for longer period of time. So, here the ATM 1 is waiting for longer time. So, the 7th customer is entering into the ATM 1. So, we are updating the time available for the ATM 1. Like this I have completed for 1000 customers. So, here what are the statistics we are using? The number of people are waiting. We can use COUNTIF in that E16 to E1015, how many people are waiting? So, 82. What is the probability of waiting? So, number of people waiting divided by total number of customers. So, 1000 0.08. So, average waiting time. So, average waiting time is, so just I find the average, we have summed the total time divided by number of people waiting. Number of people waiting is here 82. So, maximum waiting time, the max formula, number of people waiting greater than 1 minute, it is 18. The probability of waiting greater than 1 minute, say E1022 upon A1015. Now, the important summary statistics for us is average waiting time. So, if I keep on press F9, so I am going to press F9, you see that when I keep on press F9, so most of the time the average waiting time is below 1 minute. So, that is what our service requirement. So, what we are concluding here, if you have 2 ATM, that we can meet your service requirement of average waiting time is less than 1 minute. So, I will go back to the presentation. So, the summary statistics says, which is what is more important for us, the average waiting time. So, the average waiting time is 0.76, which is less than 1 minute. So, we are able to achieve the service requirement by having 2 ATM. That is the conclusion for this simulation problem. Now, I am going to take another problem which is similar to this ATM problem. So, I am going to solve it just for your understanding. A beverage company operates a chain of beverage supply stores. Each store has a single service lane. Cars enter at one end of the store and exit at the other end. Customer pick up soft drinks, snacks and party supplies without getting out of their cars. When a new customer arrives at the store, the customers wait until the preceding customer's order is complete and then drives up to the store order window for drives up to the store order window for service. Typically, 3 employees operate each store during the peak period. One clerk takes orders, another clerk fills the order and the third clerk serves as a cashier and store supervisor. The company is considering a revised store design in which computerized order taking and payment are integrated with specialized warehousing equipment. Management hopes that the new design will permit operating each store with one clerk. To determine whether the new design is beneficial, management decided to build a new store using revised design. So, what is this revised design? So, revised store design, one clerk. This new store will be located near a major shopping center. Based on experience at other locations, management believes that during the peak late afternoon and evening hours, the time between arrivals follow exponential probability distribution. Please remember, in the ATM problem, we have assumed that the arrival follow uniform distribution, but here the arrival follow the pattern of exponential probability distribution with mean of 6 minutes. These peak hours are the most critical time period for the company. Most of the company's profit is generated during this peak hours. So, we have seen the arrival pattern. Now, we will see what is the service pattern. An extensive study of times required to fill orders with a single clerk led to the following probability distribution of service times. So, service time 2 minutes, sometimes it may take 2 minutes also, 3 minutes, 4 minutes, 5 minutes, 6 minutes, even there is a possibility to take 9 minutes also with 2% of probability. So, this is the revised store design when there is only one clerk. So, consideration of second design, consideration of another two design alternative. In case customer waiting time prove too long with just a single clerk, the company's management is considering two design alternatives. So, the first one is add a second clerk to help with the bagging and taking orders and related tasks, still function as a single server system and serving one car. So, another alternative is enlarge the drive through area so that two cars can be served at a time, that is operating as a two server system. With either of these options, two clerks will be needed. With the two server options, service times are expected to be the same for each clerk, that is for single server. Now, service time with the second clerk assisting the first clerk. With the second clerk teaming with the first clerk in the single server design, service time will be reduced and would be given by the probability distribution in the following table. You see that now the service time is decreased when there are two clerks assisting for a single server. So, maximum service time is only 5 minutes. When there are two servers, that means two cars enter at a time, but with single clerk, the service time is again you see that 2, 3, 4, there is a possibility 9 minutes also. So, this problem is taken from the book Anderson et al. So, what is the questions? The company's management would like to develop a spreadsheet simulation model of the new system and use it to compare operation of system using the following three designs. What are the three designs which are proposed? One is single server system operated by one clerk. Second one is single server system operated by two clerk. Third one, two server system with each server operated by one clerk. So, the management is especially concerned with how long customers have to wait for service. Research has shown that 30% of the customers will wait no longer than 6 minutes and 90% of the 90% will wait no longer than 10 minutes. As a guideline, management requires that average waiting time to be less than 2.5 minutes. So, we are going to simulate all these three new designs and we are going to find out what is the average waiting time, whether all these three new designs, whether we are able to achieve this target, that is less than waiting time is less than average waiting time is less than 2.5 minutes. Here To generate a data set which follow exponential distribution, in Excel we have to use minus lambda, that is the mean, multiplied by log of rand. So, this function will be used in Excel for generating random numbers which follow exponential distribution. Now, I am going to summarize 3 designs, arrival and service pattern for the 3 proposed design. Design 1, arrival pattern, exponential distribution with mean of 6 and service pattern is given. And design 2, in design 2, one server, there are 2 clerks. So, here service pattern also empirical distribution is given. The third design is 1 clerk, but 2 server, it is similar to 2 ATM. In each server only 1 clerk is helping, that is why the service time is more. So, in the problem it is given the service pattern for design 1 and design 3 are same. So, now we are going to make 3 different type of simulation. For each simulation model we are going to find out what is the average waiting time. If the average waiting time is less than 2.5 minutes, we are going to recommend that design. Now, I will go back to the Excel. Now, the server operated by 1 clerk, strategy number 1. So, inter arrival time follow exponential distribution, mean is 6. Service pattern follow an empirical distribution. So, the probabilities and the that service timers are given. Here we are going to make the lower random number and upper random number, because the probability. So, here what I have done, you see that the probability is 0.24 and service time is 2. So, 0.24 I have written 0.0 is the lower random number, upper random number is 0.24. Again I started with the 0.24, the probability for 3-minute service is 0.2. So, I have added that. So, 0.24 plus 0.2, so it will be 0.04. The upper random number is 0.44. For the next one, so the lower random number is 0.44. You see that the probability is 0.15. So, 0.44 plus 0.15, so you will get 0.59. So, what I have written, lower random number and upper random number from the given table. So, I have wrote in the continuous scale. Okay. Now, we will go back to the our simulation model. Look at the customer 1. Now, you see that the inter arrival pattern, as I told you. So, the formula for generating random numbers which follow exponential distribution is minus mean B4 log of rand. So, that I have generated for 1000 customers. So, inter arrival time is for the, it is for the first customer it is same, service start time for first customer is same, waiting time, what is the waiting time? As usual it is a service, the difference between service start time minus arrival time. Then the service time, see that in the service time I have used VLOOKUP function. So, VLOOKUP, then rand, I generated I have selected A9 to C16. What is the A9? A9 is where the lower random number starts. What is the C16? Where the service time for the last value is given here, that is C16 is 9.0. Then we know that the VLOOKUP standard function is rand, then we have to generate the range, comma 3. Why I have given 3? Because the value will be picked from the third columns, that is why it is 3. So, here the service time also generated for 1000 customers. Then the completion time is service start time plus service time. So, the time in system is completion time minus arrival time. Now, we will see for the second customer. The second customer, as usual, I have generated the inter-arrival time. Then how I got 11.9? So, 11.4 plus 0.5, 11.9. Now, you see the logic for service start time. If C24, if C24 is greater than G23, what is the G23? Completion time for the previous customer. The completion time for previous customer here is 2.5. So, when we compare is 11.9 and 2.5. So, 11.9 is greater. So, that means he is coming late. So, service start time is exactly 11.9. So, there will not be any waiting time. Then service time I have randomly generated, then the completion time, then time in the system. Here I am going to find out the idle time for the server. So, idle time is E24, if E24 equal to 0, then what is the E24? If the waiting time is 0, the waiting time of the customer is 0. So, the idle time for the server is D24 minus G23, otherwise it is 0. So, like this I have find idle time for all 1000 iteration. So, finally, if you see the summary statistics, number of people waiting. So, COUNTIF in the waiting line column, how many people have waited, probability of waiting. Most importantly, see the average waiting time. The average waiting time is 9.83, but what is our requirement? It should be less than 2.5. See the maximum waiting time, sometime some customers are waiting 44.3 minutes. Number of people waiting greater than 6 minutes, 355. Probability of waiting greater than 6 minutes, 0.36. Number of people waiting more than 10 minutes, 250 people. So, here the first strategy, if I keep on press F9, so every time see the average waiting time is changing. So, most of the time the average waiting time is greater than 4, but our requirement is average waiting time should be less than 2.5. So, the first design is not suitable for us. Now, we are going to explore the second design. Here what is the second design? There is a single server, but 2 clerks are helping for providing the service. So, here arrival pattern is as usual, it is same. So, here also the random numbers which I have generated in a continuous scale, okay, 0.00, 0.20, then 0.20, then 0.55 up to 1. Then I have entered the service time, okay, 1, 2, 3, 4, 5. Now, what is the difference between the previous case and this case? Previously the service time is more because there is only one clerk, but now the service time is decreased. So, when the service time is decreasing, we are going to see what is the average waiting time. So, inter arrival time is as usual, it is same because it follow exponential distribution. Arrival time, service start time, waiting time and service time, completion time and time in system. Similarly, for the second customer, so arrival time is taken. So, you see the service start time. Service time, this customer, second customer is arriving 2.2, but the completion time is 3. So, he has to wait. How much time he has to wait? So, 3 minus 2.2, so 0.8 minutes. So, service start time, that is randomly generated from the given empirical distribution by using VLOOKUP function. So, the completion time is service start time plus service time. So, the time in the system is completion time minus arrival time. Now, look at the idle time. If the waiting time is 0 for the customer, the idle time for the server is D21 minus G20, otherwise it is 0. Now, we will go back to the summary statistics for the second design. For the second design, number of people waiting 409, probability of waiting 0.41. See the average waiting time. So, the average waiting time is 2.35 minutes. If I keep on press F9, see that if I keep on press, so the average waiting time is 1 minute Rogan, what was the target? 2.5. Okay. So, the average waiting time, most of the time it is exceeding, sometime it is within 2.5 minutes, but it is very close to our target, but many time it is exceeding. So, the second design is somewhat more suitable. So, if I press F9, see that 2.35, 2.56, 2.12, 2.57, 2.63. So, most of the time it is exceeding 2.5 minutes, but sometime it is meeting our requirement. So, this is the second design. Here what is the conclusion from the second design? Sometimes we are meeting, most of the time we are not able to meet the target, but sometime we are meeting the target. So, the second design is closer, the second design is very close to our expectation. Now, we are going to see the third design. What is the third design? 2 server operated by 1 clerk each. Here the inter-arrival follow exponential distribution with mean 6 and service time follow an empirical distribution. This problem is similar to having 2 ATM, because here there are 2 servers there. So, 2 car can enter into the shop to get their service. So, customer 1, here also we are following the same assumption. What is the same assumption? That the customer 1 will go to the server 1. After that, if any customer is entering, he will enter to the server which is idle for longer time. So, it is a 4.6. So, arrival time also 4.6, service start time of 4.6, there is no waiting time. Service time is, look at the service time we have taken from by using VLOOKUP function. VLOOKUP rand A9 to C16. The logic of VLOOKUP function is a random number will be generated, that random number will be traced between A9 to C16. If that random number is matching between A9 to C16, that corresponding value in the column 3 will be picked as a service time. That is why we got 2, because we maybe the randomly generated number may be between 0 to 0.24. So, completion time, time in system and time available for server 1. So, because we have the assumption that the customer 1 will enter into the server 1. Now, look at the second customer. Second customer inter arrival time is 10.7, his arrival time is 15.3, because already the server 2 is free. So, he will enter into the system for getting the service. So, there is no waiting time. Service time will be picked from the empirical distribution, completion time. So, now the completion time, how we are updating the completion time? For previous customer, when you look at the previous customer, the ATM 2 is free now. So, now the completion time will be updated below the ATM 2. So, it will become 18.3. The 6.6 will be carried to the next customer. The logic is same like our 2 ATM problem. So, this I have repeated for 1000 customers. I have found different summary statistics, number of people waiting, probability of waiting. Look at the average waiting time. Average waiting time is 1.65. If I press F9, see that most of the time the average waiting time is less than 2.5 minutes. So, what we are concluding, the third design is the most suitable design. That means having 2 server will help us to achieve our requirement of waiting time is less than 2.5 minutes. Now, I will go back to the presentation. So, we have seen what is more important for us. So, the average waiting time 6.27, here 2.86, here it is 1.7. So, we are recommending the third design. What is the third design? 2 server operated by 1 clerk each. Now, we will go for simulation verification and validation. An important aspect of any simulation study involves confirming the simulation model accurately describes the real system. Inaccurate simulation models cannot be expected to provide worthwhile information. Thus, before using simulation results to draw conclusions about the real system, one must take steps to verify and validate the simulation model. First, we will see what is the verification. Verification is the process of determining that the computer procedure that performs the simulation calculations is logically correct. It is largely a debugging task to make sure that no errors are in the computer procedure that implement the simulation. In some cases, an analyst may compare computer result for a limited number of events with independent hand calculations. In other cases, tests may be performed to verify that the uncertain inputs are being generated correctly and that the output from the simulation model seems reasonable. The verification step is not complete until the user develops a high degree of confidence that the computer procedure is error free. Next, we will see what is validation. Validation is the process of ensuring that the simulation model provides an accurate representation of real system. The verification is just debugging. Here the validation is whether the simulation model exactly represents the real system or not. So, validation requires an agreement among analysts and managers that the logic and the assumptions used in the design of the simulation model accurately reflect how the real system operates. The first phase of validation process is done prior to or in conjunction with the development of computer procedure for the simulation process. Validation continues after the computer program has been developed, with the analyst reviewing the simulation output to see whether the simulation result closely approximate the performance of the real system. If possible, the output of the simulation model is compared to the output of an existing real system to make sure that the simulation output closely approximates the performance of the real system. If this form of validation is not possible, individuals experienced with the operations of the real system can review the simulation output to determine whether it is a reasonable approximation of what would be obtained with the real system under similar conditions. In this lecture, I have explained the introduction of one more ATM to achieve the service requirement. What is the service requirement in our problem? The service requirement is the average waiting time should be less than 1 minute. So, we have found that by introduction of 2 ATM that we are able to achieve the requirement. Also, I have taken another problem to explain the concept of 2 server system waiting line problem to meet the service requirement. Finally, I have explained the concept of verification and validation for the simulation model. Thank you.